Hello students, in today's class let us continue with exercise 6.3. Yes, we are solving problems from exercise 6.3. In last class we have completed till 5th question, right? Now let us move on to the 6th question. What is given? They have given the diagram in the question and they have told you triangle ABE. Triangle ABE is congruent to triangle ACD. They asked you to show, kindly don't get confused with the symbols of congruency and similarity. This symbol stands for congruency and this symbol stands for similarity. Congruency imply all the corresponding paths are equal. All the corresponding paths are equal if two triangles are congruent. When it comes to similarity, all the angles, corresponding angles will be equal, but all the corresponding sides will be in proportion. They are not equal. They are in proportion. They may or may not, right? So let us continue with this. So it is given triangle ABE. ABE is this triangle is congruent to triangle ACD. We need to prove triangle ADE, this upper triangle. ADE is this triangle is similar to triangle ABC. ABC is the full triangle. So in order to prove the similarity, what are all the things we need? We need all the three angles to be equal or two angles to be equal. Minimal requirement is two angles to be equal, or one angle should be equal and the sides should be, two sides should be proportional. All the three sides should be proportional. So whenever we have to prove two triangles are similar, first look for a common angle. This is what the procedure we will do even to prove congruency in the last year, right? So check for the common angle. If they have a common angle, it's an added benefit for us because we got one angle from that itself. We don't want to search for an angle there. So if you see triangle ADE and ABC, it is very clear angle A is common, right? So we got one angle done there. Right, now let us check for, since one angle is equal, we can go for one more angle, or else the two sides, corresponding sides should be in proportion, right? Here it is given triangle ABE and triangle ACD. Now let us check for one more angle if at all is possible, because if two triangles are congruent, corresponding angles will become equal by CPCT. But here we have angle B and angle E. Here we have angle C and angle D. B will be equal to C and E will be equal to D, right? But if you check out the vertices of these two triangles, here B and E together, here D and E together. So there is no match, right? So we cannot find one more angle here. So the only possibility is with the sides. Now let us check the proportionality of the sides. So first let us always start the proof from the given part. So it is given the two triangles are congruent. So by CPCT what we know, triangle ABE is congruent to triangle ACD. Therefore by CPCT what we know, by CPCT ABE is here, ACD is here, right? By CPCT AB will be equals to side AC. The correspondence is important, again and again I am telling you. Then BE will be equals to CD, right? And also AE will be equals to AD, right? These are all the things we know. But what we need now, we need ADE and ABC. Therefore, if we have AD by AB is equals to AE by AC, then we get the proportionality of the two sides. So let us check whether are we getting there. AB and AD we need. AB is here, AD is here, right? Similarly AC and AE. Yes, so let us divide the equation 1 and 2. But this can be rewritten as, or AD will be equals to AE. Now mark this as 2. Now dividing 1 by 2, what we will get? AB by AD is equals to AC by AE, right? AB by AD is equals to AC by AE. AB divided by AD is equals to AC divided by AE, and also angle A equals to angle A, which is common angle. Therefore, by SAS similarity criteria, triangle ABE is similar to triangle ADE. Triangle ADE is similar to triangle ABC. Yes, triangle ADE is similar to triangle ABC. You can check for the correspondence as well. Angle A correspond to angle A, right? AE and AC. See, AE and AC we have. Then AB and AD we have. Yes, thus we have proved the two triangles are similar by SAS similarity criteria. So always, as I said you, in order to prove the similarity, first check for any common angle. If there are any common angle, one problem, one clue been got. So from there you can start your solution from the given part of the question. Yes, hope you understood. Let us move on to the next question now. Let us move on to the next question. What is given? AD and CE are altitudes of triangle ABC. Altitudes of triangle ABC, they asked you to show 4 things. What is meant by altitude? First of all, altitude means height. Height is the perpendicular distance. What is height? Height is the perpendicular distance. AD and CE are the altitudes of triangle ABC. So which means these two are perpendiculars. That you should remember. Altitude means 90 degree. Our first question is to show triangle AEP is similar to triangle CDP. AEP is this triangle. We need to prove this is similar to CDP. This triangle, right? We need to prove this triangle is similar to this triangle. So to prove similarity, as I told, first we should check for the angles. If any two angles are equal, if we find any two angles to be equal, then by AA similarity criteria, two triangles will become similar. So if we were unable to find two angles, if we know one angle, then you can search for the corresponding sides including that angle should be in ratio, right? Then we can use SAS criteria. If it is not there, you can check all the ratio of the sides of the triangle. If all the three sides are in proportion, then by SSS similarity criteria, two triangles will become similar. Why am I repeating all these criteria again and again for each and every problem? So that it will get memorized. You will memorize all those things. By default, with the unknowingly, it will store in your mind. So whenever you are solving problem, automatically your mind will search for those things in the question. So that's why I am repeating again and again, right? So now our aim is to prove similarity for these two triangles. How are you going to prove this? And before starting the proof, I also told you, check for any common angle. If at all you have a common angle, then it will give you a solution, right? One common angle you have arrived, then you can move further. Now if you check these two triangles, we know this angle is 90 degree, this angle is 90 degree, which is given in the question. So if we know one more angle, two triangles will become similar, right? E corresponds to D. That correspondence is also important. CED. Now we know what about these two angles. These two angles are vertically opposite angles. Vertically opposite angles will be equal. So angle P, see, P corresponds to P only here. Therefore by AA similarity criteria, triangle AEP will become similar to triangle CDP, right? I'm going to just give you the clues. You are going to solve this problem. I'll give one more a clue to solve the one more subdivision. Remaining two, I'm leaving it to you. Now ABD and CBE. Which is ABD? ABD is this full triangle, and CBE is this, right? This right triangle and this triangle, right? Now if we check out this on shading itself, we found this angle B is common. Angle B is common in both the triangles, right? Angle B is common in both the triangles. So we got one angle. This angle is there in this right triangle and even in this triangle. Yes. Now one more angle where we can go. In this triangle we have this ABD, we have this as 90 degree. In CEB we have angle E as 90 degree. Yes, we got another angle as equal, but only one thing you have to check is whether the correspondence is proper. Here E is equal to D. Check, yes, E is here, D is here. The correspondence is also same. Therefore, by AA similarity criteria again, these two triangles will become similar. Yes, likewise you can prove the remaining two subdivisions. I am leaving it to you. It's very simple. So you can prove it. So prove all the four subdivisions. For the first two subdivisions I have given you the answer. You have to write the solution, and remaining two, try solving it. Let us move on to the next question now. Now let us see how can we solve our eighth question. Eighth question, what is given? E is a point on the side AD of produced of a parallelogram ABCD. So how can you draw this diagram? First draw your parallelogram ABCD. It is given in the question that ABCD is a parallelogram and E is a point. E is a point on the side AD produced of a parallelogram ABCD. So E is not a point on AD. E is a point of the side AD produced. Okay, I repeat, E is not a point on the side AB. If it is given E is a point on AB, you can plot somewhere here. But it is given E is a point on the side AD produced of a parallelogram ABCD. And BE intersects CD. BE intersects CD at F. That's why it is named as F. Now we need to show that triangle ABE is this full triangle is similar to triangle CFB. CFB is this triangle. So we need to prove this full triangle is similar to this triangle. How can we prove? So as usual, first search for an angle. So how can we find out an angle? And one more thing I want to tell you, on looking at the naming, don't see here also B is there, here also B is there, so B is a common angle. No, don't blindly come to a conclusion on looking at the naming. Naming will give you a clue. After getting the clue, you check with your diagram. If B is there, this B is not entire angle. Here ABE, this half angle, this angle of B is only belongs to this triangle, and this portion of angle B only belongs to this triangle. The entire B does not belongs to both the triangle. That also you should check. Blindly on looking at the vertex B on both the triangle naming, you should not write B is a common angle. Okay. Now get back to this problem. Now how can we solve this? Where we can find one angle? We are talking about this triangle, and we know ABCD is a parallelogram. Yes, parallelogram property. What is the property of the parallelogram? Opposite angles are equal. We know angle A is equals to angle C, and we find A belongs to this triangle and C belongs to this triangle, and the correspondence is also there. A is equals to C, right? And one more angle we need. What is the one more angle where we can find? We know parallelogram opposite sides are parallel and equal. So this side is parallel to this side. And if you take this as your transversal, BE as your transversal, we know this angle will be equal to this angle. Why? Alternate angles are equal, right? So angle AEB, this E corresponds to B in this triangle. Yes, the correspondence also holds good. Therefore, by AA similarity criteria, these two triangles will become similar. Yes, so how will you give your proof here? Given ABCD is a parallelogram, we know opposite angles are equal. So angle A equal to angle C, and also CD is parallel to AB, and considering BE as our transversal, this angle AEB is equals to angle FBC, since alternate angles are equal, and hence by AA similarity criteria, these two triangles will become similar. Again, I am leaving this question to you. You are going to write the proof. I have given you the solution. You are going to present the answer neatly. Every time if I do it, you don't get that training. So that's why I am leaving it to you. So give neatly the solution of the problem in wordings. Yes. Let us move on to the ninth question. Ninth question is so easy, which can be proved by yourself. ABC and AMP are two right triangles, right angled at B and M respectively. Where is the diagram? 6.39. Prove that ABC triangle is similar to triangle AMP, right? AMP is this triangle and ABC is this triangle and AMP is this triangle. They asked you to prove, and they have given two angles are at right angle and BMM, it corresponds directly, and angle A is common in both the triangle. Therefore, by AA similarity, both will become similar, and this correspondence will follow directly since two triangles has become similar. So I am giving this problem as homework to you. Let us move on to the next question. CD and GH are respectively the bisectors of angle ACB and EGF such that D and H lie on sides AB and FE of triangle ABC and EFG respectively. So first let us draw the diagram. Triangle ABC. This is triangle ABC, and there is another triangle EFG. There is another triangle EFG, right? CD and GH are respectively the angle bisectors of angle ACB. So which means this angle is equal to this angle, and EGF, so this angle is equal to this angle, right? And this is D, this is H, lie on the sides AB and FE of triangle respectively. Now what is given in the question? It is given triangle ABC is similar to triangle FEG, right? And we need to show three things. One is CD by GH is equals to AC by FG, and the second thing is triangle DCB is similar to triangle HGE, and third thing is triangle DCA is similar to triangle HGF. These three things we need to prove. This problem also can be solved very easily because in the question it is given triangle ABC is similar to triangle EFG. So we know all the corresponding angles will be equal. Angle A will be equal to angle F, angle B will be equal to angle E, angle C will be equal to angle G. That is A. This is your angle A, right? Angle A is equals to angle F. Angle E, where is angle A? Angle B equals to angle E. This is your angle B. Angle B equals to angle E. Angle C, this full angle will be equals to angle G, right? This full angle is equals to angle G. So this is what given in the question. Now we need to prove CD by GH. CD by GH is equals to AC, I'm sorry, this is C. AC by FG. AC by FG. So CD by GH. CD by GH is equals to AC by FG. So the first relation is about this triangle and this triangle. So if we prove these two triangles are similar, then the ratio will follow automatically. because if two triangles are similar, the corresponding sides will be in proportion. So try to prove the similarity of these two triangles. What we know about these two triangles? We know angle A is equals to angle F. And what about this angle and this angle? This complete angle is equal to this complete angle by similarity criteria, which is given in the question, but which is also added in the question that CD and GH are angle bisectors. Therefore, this will be equal to this and this will be equal to this. So, when the full angle is equal to this full angle, then automatically half of this angle will also be equal to half of this angle. Yes or no? Therefore, angle ACD will be equal to angle HGF. HGF. So, this small angle, this angle will be equal to this. Already we have proved A is equals to F. Therefore, by AA similarity, these two triangles will become similar. Once similar, the correspondence will follow as such. CD will be divided by GH is equals to AC divided by FG. Right? Hence, we proved the first subdivision. Similarly, you can try the remaining two subdivisions. DCB is similar to triangle HGE, which means this triangle and this triangle we need to prove similarity. The same way, this angle B is equal to E, already it is given in the question, and also this part of the triangle, this angle will be equal to this angle because we know this complete angle is equal. So automatically half of that angle will be equal. Only thing you have to check here is correspondence. B corresponds to E. Yes, B corresponds to E, and if you check DCB, this angle corresponds to G here. Yes, and D corresponds to H. Automatically it will follow. Similarly, you can try the third subdivision. You will easily get the answer. Now let us move on to the 11th question now. Let us move on to our next question. It is given that ABC is an isosceles triangle. What do you know about isosceles triangle? Two sides will be equal and hence the opposite angles will also be equal, right? So it is given AB equal to AC. So we know this angle will be equal to this angle, right? And also it is given AD is perpendicular to BC and EF is perpendicular to AC. We need to prove that triangle ABD is this triangle is similar to triangle ECF. ECF is this triangle. We need to prove this triangle is similar to this triangle. Now by then you might have got a clue. What criteria? AA similarity criteria, because we got this angle is equal to this angle. This angle corresponds to this triangle and this angle corresponds to this triangle, and also we have perpendicular, so which means 90 degrees. So angle F corresponds to this triangle and angle D corresponds to this triangle. Therefore by AA similarity criteria. But only thing, again you need to check the correspondence. D of this triangle corresponds to F of this triangle. Yes. Then angle B of this triangle corresponds to angle C of this triangle. Yes. Remaining is A and E. Therefore, by AA similarity criteria, the two triangles will become similar. That's it. Right? Hope you will complete this problem by your own. Let us move on to our next question. Sides AB and BC and median AD of a triangle ABC are respectively proportional to sides PQ and QR and median PM of triangle PQR. Show that triangle ABC is similar to triangle PQR. First of all, diagram is diagram is given here. See, side AB and BC and median AD of a triangle ABC are respectively proportional to sides PQ, QR and median PM, respectively proportional. So how can you write AB by PQ equals to BC by QR equals to AD by PM? The proportionality is given. We need to prove the entire triangle ABC is similar to triangle PQR. Now let us see how can we prove this. Now see, this is what given in the question, right? AB by PQ is equals to BC by QR equals to AD by PM. This is what given in the question. We need to prove the entire triangle ABC is similar to triangle PQR. To prove the similarity, what we need? Again, we need two angles, or one angle and two sides, or three sides, right? But already we have a clue. AB is proportional to PQ and BC QR, right? We got AB and BC, this side and this side and this side already in proportion. The third side they didn't give, instead they have given about the median. Now, to prove these two triangles are similar, either we should tell the third side is also similar, third side is also in proportion, or else the included angle of these two sides are equal. If we prove the included angles are equal, then we can say by SAS criteria these two triangles will become similar. Now let us try how can we tell this included angle is equal. For that, we can try to prove thus this smaller triangle is similar to this smaller triangle. We try to prove this triangle is similar to this smaller triangle. If we prove this triangle is similar to this smaller triangle, then by similarity criteria we know the corresponding angles will become equal. Therefore, angle B will become equal to angle Q, and that if we can use it here, and we can say the entire triangle ABC is similar to triangle PQR. Now, how can we prove the similarity of these two smaller triangles? Again, for these two smaller triangles, we need only this smaller part, BD and QM. But in the question, we have this complete BC and QR. Otherwise, the other two sides we have, right? So, how can we bring this BD from BC? In the question, it is given AD is the median. What is the property of a median? Median will divide the opposite line into two equal halves. Altitude means perpendicular. You should remember, altitude means perpendicular, median means midpoint. Median means midpoint. You should remember. So, in the question it is given AD. It is given that AD and PM are medians. So, this implies BC. If AD is a median, BC can be written as 2 times BD, right? BC can be written as 2 times BD, or else BD will be half of BC, or BD is half of BC. Similarly, what can you write? This QR can be written as, since PM is a median, 2 times QM, or QM is half of QR, right? Now, what are we going to do it now? Now, we are going to apply this in the given ratio. Where are we going to apply? In the place of BC and in the place of QR. Instead of BC, we are going to write half BC, which is nothing but BD, and in the place of QR, we are going to write half QR, right? Therefore, 1 will become AB by PQ. We are going to divide, both multiply and divide by half. Half BC will be same as half QR, which is equals to AD by PM. But we know what is half BC. Half BC is BD and half QR is QM, right? So, now we are going to replace the numerator by BD and denominator by QM. So, after replacing that half of BC and half of QR as BD and QM, we got our required proportion. What proportion we got? The required sides. AB by PQ equals to BD by QM equals to AD by PM. Therefore, by SS's similarity criteria, this smaller triangle will become similar to this smaller triangle. Therefore, corresponding angles will become equal and hence angle B will be equals to angle Q. That's what I have written here. Now, but our aim is to prove triangle ABC is similar to triangle PQR. As I explained earlier, we got the proportion of two sides and just now we proved the included angle is also equal. Therefore, by SAS similarity criteria, the two triangles will become similar. That's it. Yes, hope you understood. Yes, let us move on to the next question. Let us move on to 13th question. D is a point on the side BC of a triangle ABC such that angle ADC equals to BAC. Show that CA square equal to CB into CD. Right? So what is given? Let us draw a diagram. D is a point on the side BC of a triangle ABC. So this is your triangle ABC and D is a point on BC such that ADC, this angle is equals to angle BAC, which means this full angle. So what is given? Angle ADC is equals to angle BAC. This is what given in the question. They asked you to show that CA square is equals to CB into CD. This is what they asked you to show. So how can you analyze this? So this is what we need to prove. This can also be written as CA into CA square, CB into CD, right? Which means we need to prove CA by CB is equals to CD by CA. So if we prove this, automatically we can arrive at this. So you don't want to get panic on looking at this. This is nothing but the proportion of two sides of two different triangles. Now we need to check which two triangles are we talking about. From the hint given in the question, you can choose your triangle. The hint is about this angle and this full angle. So take triangle ADC and ABC completely. Okay. So we are going to consider triangle ADC and triangle ABC. We are going to consider ADC and ABC. What we know, angle ADC is equals to angle BAC, which is given in the question. So we got one angle. In order to prove the similarity, we need another angle, right, or else two sides. But we can see that ABC is this full triangle. ABC is this full triangle and ADC is this. So what you infer? This angle C is common for both the triangles. So you can write angle ACB is equals to angle AC. See, ADC we have written, therefore it should be ACD. We are talking about angle of the smaller triangle, and here ACB, okay, which is a common angle. So we got two angles. Therefore, by AA similarity criteria, triangle ADC will be similar to which triangle? The correspondence is important. Now if you check angle ADC, angle D corresponds to angle A of this bigger triangle. Angle D is equal to angle A. So where you have D, there you have to write A, right? And C is common in both the triangles. So you have C, so C should be the last vertex of the other triangle as well. So what is left out? B. So this A corresponds to B of this triangle. Therefore, triangle ADC is similar to triangle BAC. Hope you understood. If you change the correspondence, the entire thing will go wrong. Correspondence is very, very important. So how I wrote this? This given angle D is equals to angle A. So where you have D in this triangle, in that place you have to write A. And C is common, so write C in the same place. And the other vertex you can place it. Right? Now we got the similarity criteria. This implies what? The corresponding sides will be in proportion. So which are the corresponding sides? AD, right? AD by BA is equals to DC or CD. Okay, DC divided by AC, which is equals to CA divided by CB. Yes, but our aim is about this only now, because this is what they need to prove. So take this alone. Now if you cross multiply, what will happen? This implies CA into CA is equals to CB into CD, which is nothing but CA square is equals to CB into CD. That's what we need to prove. I'm sorry, CD. That's what we need to prove. So hence we proved. Right? Hope you understood. Again, the proof of the question follows very easily. The only thing is you have to understand it, analyze it properly and present your answer. That's it. Let us move on to the next question. Hope you understood. Now come back to 14th question. This is similar like our 12th question. Here they have given AB by PQ, AC by PR and AD by PM are equal. That is, in the question it is given that the sides AB, then AC and AD of AD is the median which is given in the question of triangle ABC are respectively in proportion to the sides PQ, PR and PM. Right? In the previous question they have given proportion about these two sides and the median. These two sides and the median. These two sides and the median. So what we did? We proved the similarity of this smaller triangle using the definition of the median, that it will divide the opposite side into two equal halves. This will be equal to this. We have replaced in the given proportion and we proved the similarity. Then we got corresponding angles are equal. Therefore, by SAS similarity criteria, we proved the entire triangles are similar. But here in this question, instead of the base, they have given the proportion for this side and the median. Right? So how can we prove this? Again, they asked you to prove the entire triangles are similar. So we got the proportion of two sides. So if we prove this included angle is equal, then by SAS criteria, similarity criteria, two triangles will become similar. So how we can prove these two angles are equal? What are we going to do is, we are going to construct the triangle. What are we going to do is extend the side AD and PM up to E and L. What are we going to do? You extend this AD and PM. We are going to extend this to E and this to L, same, such that AD will be equals to DE and PM will be equals to ML. What are we doing? We are going to extend this AD to E and PM to L such that this equal to this and this equal to this. Now join this BE and EC. Join QL and QRL. Right? Now what we know this ABCD is a quadrilateral and we know this AD is the median. Therefore, it will divide it into two equal halves. This will be equal to this. Right? So now ABCD is a quadrilateral in which this is equal to this and this equal to this. So which implies the diagonals bisect each other. So if in a quadrilateral diagonals bisect each other, then it will become a parallelogram. Right? So ABCE is a parallelogram. Similarly, PQRL is also a parallelogram. What are the properties you know about a parallelogram? Opposite sides are equal. So we are going to use this property in the given condition. Instead of our AB, we are going to replace it by CE because opposite sides are equal. Instead of one proof and another one, instead of AC, we are going to replace it with BE and we will try to prove this triangle, this half triangle is similar to this triangle. If this triangle is similar to this triangle, we know this part of this angle will be equal to this because corresponding angles will be equal. Similarly, we can prove this part of the triangle is similar to this part of the triangle. Then again by corresponding angles will become equal, therefore this part will be equal to this. So if you add 1 and 2, we will get the complete angle is equal to this complete angle. Right, and hence by SAS criteria the two triangles will become similar. This is the idea behind this problem. I repeat, what are we going to do? We are going to extend this AD to E such that this will be equal to this and this is equal to this. Then automatically this quadrilateral will become a parallelogram since diagonals bisect each other. In a parallelogram, we know opposite sides are equal. We are going to apply this property in the given proportion in order to prove this triangle is similar to this and this triangle is similar to this. Then by the property of similarity, the corresponding angles will become equal, and if this part will become equal to this and this part will become equal to this, and if you add 1 and 2, entire angle A will become equal to an entire angle P. Therefore, by SAS similarity criteria, triangle ABC will become similar to triangle PQR. Yes, hope you understood. Let us see how can we present this answer now. Now see how we have presented the answer. Extend AD and PM. Extend AD and PM to E and L respectively such that AD is equals to DE, PM is equals to ML, and we have joined these two things. So now the quadrilateral has become parallelogram since the diagonals bisect each other and we know opposite sides are equal. That is AC equals to BE and AB equals to EC. Similarly in the other triangle. Now according to the question, this is what the proportion given. Now what are we going to do? Replace this AC and BE. Instead of this AC and PR, we have written BE, and instead of PR we have written QL, right? And instead of this AD we have written twice AD. We have multiplied to both numerator and denominator because we are concentrating this entire triangle. We got AB and BE, now we need this AE, so which is twice AD. Then only we can write AE because this part is equal to this part, right? So we have multiplied both numerator and denominator by 2. Now twice AD can be written as AE, twice AD can be written as AE, twice PM can be written as PL. So we have replaced. Now we got all the three sides of the triangles are proportion, therefore two triangles will become similar. And as per our discussion earlier, the part of the angle A and angle P will become equal since corresponding angles are equal. Similarly, we can prove the other side. Similarly, we can prove this part of these two triangles are similar. So we will get this. By adding 1 and 2, we will get the entire angle A is equals to entire angle P. And also from the given statement, we have the ratio of two sides. Therefore, by SAS criteria, the two triangles have become similar. Yes, hope you understood the entire proof. Yes, let us move on to the next question. Let us move on to our next question. A vertical pole of length 6 meter cast a shadow 4 meter long on the ground, and at the same time a tower cast a shadow 28 meter long. Find the height of the tower. So there is a pole and a tower, both cast shadow and the shadow length is given. The height of the tower is not given, but the height of the pole is given. We need to find the height of the tower. So how can we present our answer here? See, let us take AB as our pole and PQ as our tower. And AB is the length of the pole, which is 6 meter, and the shadow length is 4 meter. Similarly, the tower height is not given. The length of its shadow is 28 meter. They asked you to find this. If we prove these two triangles are similar, we can apply the proportionality of the sides and we can find this height, right? And we know the shadow and the actual image will be at 90 degree, right? Therefore, these two angles are 90 degree. The image and the shadow, right? The actual person and the shadow will be at 90 degree, obviously. So it is 90 degree. Then, and also at the same time, it is given in the question at the same time. At the same time, sun rays will fall on the same angle only, right? At the same time, the sun rays will fall on both pole and the tower at the same angle. Therefore, this angle will also be equal to this angle. Therefore, by AA similarity criteria, two triangles will become similar. Therefore, the sides will be in proportion. AB by BC equals to PQ by QR. If you cross multiply, you will come to know what is the height of the tower. Right? Very easy problem. Hope you understood. Let us move on to our last question in this exercise. If AD and PM are medians of triangles ABC and PQR respectively, where triangle ABC is similar to triangle PQR, prove that AB by PQ is equals to AD by PM. This is like the reverse of problem 14 and 12. See, AD and PM are the medians of two triangles where ABC is similar to triangle PQR. In both these problems, we have proved that the two triangles are similar. It is like converse. Here they have given the two triangles are similar. They asked you to prove AB by PQ is equals to AD by PM. If we perform the steps what we did in 14th and 12th in the reverse way, you will arrive at the solution. I am giving this as a homework. It is very easy proof only. ABC is similar. So, if it is similar, what are all the conditions you know? All the corresponding angles are equal and we know the sides are in proportion. So, AB by PQ is equal to AC by PR equals to BC by QR. That we know. We need to prove AB by PQ is equals to AD by PM. So, if we prove that these two triangles are similar, then this ratio will follow. So, try to prove these two triangles are similar with the given things. What is given? The corresponding angles are equal and the corresponding sides are in proportion. So, try to prove this. I am not interested in spoon feeding you. So, if you are not getting the answer, get back to me. I will explain you. Right. So, with this we can wind up today's class and we have completed this exercise. Initially when you see, it may look like a vague thing, but when you repeatedly practice, it is very easy. The solution follows easily. By repeatedly we are using AA similarity criteria, SAS and SSS. Only 3 criteria are there. Right. Do these problems as homework and go through the entire exercise and even the chapter fully till exercise 6.3. Then only you will get a better idea. So, every day when you are learning, go through the previous concepts what we learnt in the chapter so that it will be easy for you to remember. Right? If you have any doubts, ask me students. Thank you.